Welcome to another PYTHA tutorial in which we take a look at the Profile command in the Parts menu. Next to the default parts that you will learn about in the video of the same name, the Profile plays an important role in 3D modeling. In PYTHA, the Profile command is used to create three-dimensional parts from two-dimensional cross-sections. This makes it easy to create worktops with curves, floor panels, curved walls, profile strips, logos, and so on. For a profile, you always first need a 2D cross-section. This can be defined by points, edges, faces, curves, and auxiliary lines. The Profile command sweeps the existing cross-section perpendicularly and creates skin faces. This creates a 3D solid of any length from the cross-section. So much for the theory, but now let's make a profile together. To do this, we first need a two-dimensional cross-section as a basis. I switch to the XY view and open the Faces menu. There I activate the Rectangle command. Left-click to define the position of the first corner point. Without pressing a mouse button, I now move the computer mouse roughly in the direction in which I want to create the rectangle. Another left click would confirm the current size of the rectangle. However, I would like to define exact dimensions. To do this, I enter 1000,500 on the keyboard and press the Enter key. We could already apply the Profile command to this face. This would simply create a block with the rectangle as the base. But let's add a little more complexity. We activate the Circle command in the Faces menu. The input field wants to know the position of the center of the face. I select the top left corner of the rectangle. The input field asks for the radius. I enter 100 and press the Enter key. Now I right-click on the circle and select the Move command. I want to move it 300 mm to the right and 250 mm down. So I enter the following directly on the keyboard: 300, minus 250. Enter. At the moment, the circle is a separate face on the rectangle. However, it should form a hole in the rectangle. To do this, I click on the cheese icon to go to the Boolean operations. I select the Difference command, with which I can subtract parts or faces from other parts or faces. I can use this command to create holes, bores, and depressions. The input field asks, Pick part to remain. I select the rectangle with a left click. As I can only select one element as the remaining parent part, I do not have to confirm the selection. The input field immediately asks for the parts that are to be subtracted from the parent part. I select the circle and confirm the selection with the middle mouse button. Now my rectangle has a hole. Next, I would like to round at two of the corners. As the geometry I want to edit is a face, and so a 2D part, I switch to the Face Tools menu. However, if you want to round three-dimensional parts, use the Fillet command in Part Tools 1 menu. In the Face Tools menu, I activate the Fillet 2D command and select the bottom left corner. As soon as I have confirmed the selection with the middle mouse button, the Fillet dialog opens. In this dialog, I enter 250 for radius and 12 for segments. The value for segments specifies how many small straight edges are used to form the arc. The more edges you create, the rounder the arc appears. However, as many segments also increase the complexity of a part, you should always proceed according to the principle, as many as necessary, as few as possible. I repeat the steps for the top right-hand corner. This time I check the inverted box in the fillet dialog to create a concave arc and increase the radius value to 300. Now I'm happy with the shape of my cross-section. Next, I switch to the Parts menu to create a 3D part. Here I activate the Profile function. A dialog immediately appears in which I can define the desired properties of the new part. At this point, it is advisable to switch to the axonometric view. This is because as soon as the profile dialog is opened, PYTHA already generates a preview of the new part. If I change a value in the dialog, the corresponding result is immediately displayed in the construction area. In most cases, you only want to pull out the base area straight. To do this, I activate the Straight Simple option and enter the desired value for total length. A little tip at this point, you can always enter a unit of measurement in such dialogues in PYTHA. As you can see below, I am currently working in millimeters. Accordingly, the number 200 entered here in the dialog is treated as a millimeter. Alternatively, I can also enter 20 centimeters or 0.2 meters. As you can see, the model has the same height in all three cases. PYTHA automatically converts the units for us. The section setting is only relevant for very specific modeling tasks and can be ignored for the time being. Under base height, I can enter a distance to the selected base face. If I enter the value 300 here, for example, my profile will hover above the base face at this distance. As usual, the camera of the construction area can be rotated at any time using the right mouse button. This allows you to check result of the entered values from all sides. We have already created a simple straight profile. As soon as we exit the dialog using the OK button, it is added to our project and can be edited further. But first, let's play with the settings of the dialog a little more to get to know the other functions. Next, I activate the Rounded option. PYTHA automatically adopts the values total length and base height from the straight profile, which we can of course change as required. Additional input fields are also enabled. For example, we can use a numerical value in the angle field to ensure that the part tapers upwards by the angle entered. Entering a negative angle enlarges the part towards the top. The sections in straight part value is identical to sections for a straight profile. As already mentioned, this is only required in very special applications. The profile can be rounded using the other settings in the dialog. You can define different properties for the upper end of the profile and for the lower end. Accordingly, these value refer to the top of the profile and these value refer to the bottom. If you want to use the same settings for the top and bottom, simply activate the Symmetric Bottom Top command. In this case, you only need to make changes to bot. The corresponding values for the top will change automatically. As you have just seen, you define the size of the rounding under radius. You can even enter values here that would lead to a self-intersection. Luckily, PYTHA calculates a clean, smooth surface even in these cases. As previously explained for the rounding of the rectangle, roundings in PYTHA are approximated by edges or flat faces. This simplification makes three-dimensional construction much easier. The pieces that form the rounding are called segments. The more segments I create, the smoother the curve appears. But here too, you should proceed according to the principle, as many as necessary, as few as possible. Please also bear in mind that using just one segment creates a chamfer. You can choose between different rounding types using the number buttons under Shape. As soon as you are satisfied with the settings, exit the dialog by pressing the OK button. By the way, the geometry of an existing part can also be used as a cross-section for a profile. For example, I can create a second part that fits exactly into the hole in my panel. But before I do this, I change the default pen below from the black pen number 1 to the red pen number 27. This change means that all parts that I design from now on will be drawn with the red pen set here, so we can immediately see which part is the new one. Now I activate the Profile command in the Parts menu again. When I called the function earlier, there was only one face in my project. PYTHA therefore assumed that we wanted to create the profile from this and opened the Profile dialog directly. This time, however, my project contains many more elements that can be used as a cross-section. I therefore have to make a selection first. As mentioned at the beginning, the cross-section of a profile can be defined by points, edges, and faces. PYTHA therefore queries the geometry type that we want to use in the first step. I choose Edges. Next, the Query field prompts me to select a chain of edges. Now first take a look at the Chain of Edges button in the vertical menu. If this is set to -, you have to pick each individual edge separately or draw a frame selection. In most cases, the selection is much quicker if you activate this toggle switch. A tick symbolizes that the function is now activated. If I now pick one of the horizontal edges of my 3D part with the left mouse button, all horizontally connecting edges are automatically selected. As soon as the selection meets my expectations, I confirm it with the middle mouse button. The Profile dialog appears with the last settings used. This time I activate the Straight Profile type. As already mentioned, the value for base height defines the distance between the picked cross-section and the base of the new part. I initially enter a 0 here to make this clear. I increase the total length to 300 millimeters. I can also enter a negative value in this number field. In this case, the part grows in the opposite direction. The same applies to the base height. A positive value moves the part downwards in our current case. A negative value moves it in the opposite direction. The part now has the desired size and position, and I can leave the dialog by pressing the OK button. You have probably already noticed that the Profile dialog contains a third option called Modulated. With this type of profile, the selected cross-section is not simply extruded straight, but deformed using a guideline. This guideline must be drawn separately. In addition to the height of the resulting profile, it also defines the shape of the skin faces. In this way, profile doors, deep-drawn elements, columns, turned table legs, stair posts, bowls, etc. can be created. Let's try it out now. First, I press the Undo button several times to undo the last steps. This takes me back to my base face. Next, I want to draw the required guideline. To do this, I switch to the XZ side view and go to the Edges menu. In this, I activate the Polyline command. The Query field asks for the start point. The black line you see on the X-axis is our cross-section in side view. I pick the starting point at the rightmost point of the cross-section face. In other words, where the black line ends. The Polyline dialog appears. In this dialog, make sure that the angular grid is switched on and degrees has a reasonable value. Now make sure that the input focus is in the number field L, meaning the length. To do this, click in the input field and then move the mouse back into the construction area. The number is highlighted in blue. As soon as you enter a value using the keyboard, it will automatically be entered in the number field. Now we can start drawing the guideline. To do this, I move the mouse, without pressing a button, in the desired direction. Now enter 50 and press the Enter key. After the starting point, the second point of my line is now set. I now move the mouse horizontally to the left and enter 20. Enter. Next, I want to integrate a slant. Again, I move the mouse roughly in the desired direction. The previously activated angular grid helps me here. I pay attention to the phi input field when moving the mouse. As soon as the correct angle appears here, I enter the desired length again using the keyboard and press Enter. I repeat this procedure for 2 more edges. I end the command with the right mouse button. This already looks quite good, but I would now like to round 2 of the corners. As I don't want to edit faces or 3D parts this time, but only individual edges, I switch to the Edge Tools menu. Here I press the Fillet button. PYTHA asks me which corners I would like to round. I select these 2 with the left mouse button and confirm the selection with the middle mouse button. In the Fillet dialog, I enter the radius 10 and decide on 4 segments. Now I have constructed a guideline. The preparations are complete, and I can call the Profile command again in the Parts menu. I select Face as the cross-section type. As my project only contains one face, the selection is omitted, and the Profile dialog appears immediately. I activate the Modulated option here. Now I can select a chain of edges in the modelling area with the left mouse button. I select the polyline I have just drawn. We can immediately see how the shape of the profile is influenced by the guideline. If we look at the resulting part from the side, we can see that the picked guideline forms the outline of the profile. In principle, it does not matter where in the project you have drawn the guideline. PYTHA automatically places it on the cross-section in such a way that a meaningful 3D part is created. With the various checkboxes here in the dialog, the guideline can be aligned to the cross-section so that the desired shape is formed. If the result does not immediately look as expected, simply try out different combinations. Tip: if you want to use the same guidelines more often, simply save them in a separate folder. You can then access them very quickly using the Import Outline button. However, it is even quicker if you add this folder to your PYTHA drag and drop libraries. As soon as this has been done, all you need to do is double-click on the thumbnails. The Modulated command will then immediately display the corresponding profile. Finally, I would like to show you a few typical applications where you need the Profile function. First, I import a floor plan drawing created with a third-party CAD system via the DWG interface. Since the walls are available as faces, I can transform them into 3-dimensional solids in PYTHA with just a few mouse clicks. Thanks to the Profile function, the outline of the counter design quickly forms a 3D part, which can then be further edited. As the floor slab of the vestibule is not available as a chain of edges, I use the Points cross-section type and simply pick the existing corner points. The profile command also quickly transforms logos like this one into three-dimensional parts. I hope you have got a feel for when the profile command is used, and I hope you enjoyed trying out the function and look forward to seeing you again in our next tutorial.